Advanced Algebra Chapter 7 Lesson 8, and we want to wrap this chapter up by looking at some graphs of these radical expressions that we've been looking at. Now, we haven't looked at graphs for a while, so I want to do a quick review, because the key thing to be doing, to be able to do these graphs is to, when I see the equation, to get a mental picture. Okay, I know what the general shape of the graph looks like, I know what some of the key points are, and then I just want to move it right or left, up or down, reflect it over the axis, or stretch it. So all of those things that we learned earlier this year are the same, so I'm going to review that very quickly. You remember that when we had the absolute value of x, very quickly, the first picture I should get as soon as I see absolute value, okay, whoops, that's not very good. My mental picture is, okay, that's a V. I got a side going up here and a side going up here. As soon as I see this, I get a mental picture of what the graph is like. You remember then, if we subtracted a value in here, let's call this, let's see, they're going to call it H, so let's call this H. That moved the graph right or left. So rather than the vertex being here, this moved it maybe over here, where this distance here is H. Okay? So when we put something inside, that moved it to the right or left. You remember, if we put something on the outside, let's call this K, well, that moved this vertex and it moved it up. Okay, so number outside moved it up. So this distance here was K. Okay, then you remember another thing, if we put a negative sign in front, that reflected it over the x-axis, so rather than it opening up, it opened down. Okay. And then you remember that if we put a value inside here, 3x, or for the absolute value, if we put a value outside, you remember that squeezed or stretched the graph, so then it might look like this. So this distance is short because now I have a slope of 3. So all of these things that we learned earlier this year in relations to the absolute value apply to every single function that we're ever going to look at. So all we have to be able to do is to look at the equation, get an idea of what the picture looks like, and then just move it right or left, up or down, reflect it, or stretch or shrink it. Now again, earlier this year we looked at linear equations. So as soon as I see something like this, my mental picture should be, okay, that's a line, it goes through the origin. And then as I start adding these things, it moves it up or down, stretches it, or reflects it. We already looked at absolute value, so as soon as I see absolute value again, I should think V. And we looked at quadratics, and as soon as I see that, I should think U. Okay, so I get the mental picture first, and then everything else is a shift of that, or a transformation of that. So in this lesson, we want to look at two more types of graphs that we need to be familiar with. We want to look at what does the shape of the square root of x look like, and what does the shape of cube root of x look like. And actually, this is what does x cubed look like. We haven't looked at this one a lot, but we're going to look at that because it's tied to this one. So we're going to look at three new functions, and your job is to know, okay, as soon as you see that, what's the general shape, what are some key points, and then we're just going to move it. Remember, with the absolute value, the key point was the vertex, and all I did was move the vertex. Same thing for the quadratic. I just moved the vertex. And here, what are the key points that I need to know, and how are they going to move? Okay, so having reviewed all that, let's take a look at these functions. So to finish off this video, we'll take a look at these radical functions, how we move them, then we'll look at how we solve by graphing, and then how we can rewrite radical functions to help us see the shifts, because sometimes we have to do that. Now, just a quick introduction. You remember we had the vertical line test, that if we use a vertical line on this graph, if it only crosses in one place, then we know that this is a function. Well, the question is, will the inverse be a function here? And the inverse, you remember, is formed by rotating, making the x-axis become the positive y, and the positive y become the positive x. So we can tell if the inverse is going to be a function by applying the horizontal line test. In other words, if I draw a horizontal line, you'll notice that it intersects this parabola in two places. That tells me that the inverse will not be a function. And sure enough, if we graph the inverse and then apply the vertical line test, you'll notice it crosses in two places. We also notice from the equation that it's plus or minus, so it's not a function. So the inverse of the x squared function is not a function. However, if we limit the domain of the original function to just positive numbers, then we do the horizontal line test, you'll notice that the inverse is a function. And this is the function, the square root of x. And so this is a very important function for us, and so we want to look at it. So this square root of x function is, we're only taking the positive value. So what I want you to notice here is the shape of this graph, okay? All square root functions are going to look like this. And then everything else is going to be a shift of this function or a transformation. We're either going to stretch it or shrink it, we're going to reflect it, or we're going to move it right or left, or we can move it up or down. Okay? Now, there's two key points I want you to notice on here. There's 2 points. And these 2 points are the ones that you're going to shift. This point 0, 0 is always on the graph of a root function, square root function. So you're always going to graph 0, 0, and then that's the point we're going to use as a reference to move right or left, up or down, or reflect it. A second point that is always on the graph is the point 1, 0. No, not the point 1, 0. The point 1, 1. Over 1, up 1 is always on the graph as well. Again, if I put in 1 and I take the square root of that is 1. So those 2 points are the 2 points that I want to see labeled on every graph, and how I'm going to judge whether you've got the stretch or the shrink, or how you've gotten the shift right or left, is the label of these points. Okay, the rest of the graph is just a nice slow climb. Okay, so that's the square root function. Now I want to take a look at the x cubed function. Okay, and its inverse. This is the function x cubed. Okay, it always looks like this. Again, everything else is going to be a shift, stretch, shrink, reflection. And then this is the cube root. It's the inverse function. So again, if you imagine taking this function, make the positive x, the positive y, the positive y, the positive x, so you turn it and flip it, this is what the cube root function looks like. Now for this function, there's 3 key points that I want to see labeled on every function. Okay, so the point 0, 0 is on every cube root function, and then the point 1, 1 is on every function, and the point negative 1 is on every function. So those 3 points are the ones I want to see labeled on every graph, because again, that's how I'm going to tell whether you shifted them correctly. And the same 3 points are on the cube root function. Okay, so 0, 0, negative 1, and then 1, 1. Those are your key points. I'm trying to go too fast and it's not looking very well here. Let me do that one more time. Okay, negative 1, and then this point 1, 1. Those are the 3 points that I'm going to look on for every cube root function and every cubic function when you graph them. Now these are called radical functions because they're of the radical family, so that's what we're going to look at. And again, we have the parent function, and then everything else is just a reflection. So again, or a transformation of this function. Again, I've already covered this, but this chart covers that. The negative sign in front is a reflection. A number in front is going to stretch it or shrink it. A number underneath is going to move it right or left. A number outside is going to move it up or down. And you can use one or any of those to transform these functions. So all we've learned from earlier this year applies. So this is something that you'll need to know, and then it's simply a matter, whoa, just lost my lights. Did I just go black here? I don't know, just lost my lighting, so hopefully you can still see me. Or maybe you prefer not to see me, I don't care, whatever. You're going to hear me anyways. Well, as long as you keep it running, you can always shut me off whenever you want. Okay, off the basics. I mean, know the basics, off the tangent. Okay, so know the basics. So the square root function looks like this. All of them look the same, 0, 0, and 1, 1. The cube function always looks like this, negative 1, 0, 0, and 1, 1. And then the cube root function, again, negative 1, 0, 0, 1, 1. Know these shapes, know them like you know the back of your hand. And I don't know why we say that, because I have no idea what the back of my hand looks like, but It's something we've said. So I'm going to end that right here. I think I'll do an example video where I will do a number of examples of graphing these functions using our knowledge of transformations in order to do that.